Welcome to Learn Engineering Basics channel. Today we are going to discuss about what is the EMF equation of a DC generator and what is the back EMF equation of a DC motor. As the armature rotates, a voltage is generated in the coils. In the case of generator, the EMF of rotation is called generated EMF or armature EMF and is denoted as EG. In the case of a motor, the EMF of rotation is known as back EMF. In case of generator, it is called as generated voltage. In case of motor also, a voltage will be generated due to generating action, that is called back EMF or counter EMF and is represented by EB. The expression for EMF is same for both the operations, that is for generator as well as for a motor. For a DC generator, if it acts as generator, what is the generated voltage equation? Similarly, when it acts as motor, what is the generated voltage in motor? That is called back EMF. The expression discussed now. The derivation of EMF equation of a DC machine, that is generator or a motor, both are same. In case of generator, it is called EG. If it is a motor, it is called back EMF EB. Let so many terms we have to assume to derive that. P is the number of poles of the machine, that is number of poles is denoted by P, and second is flux per pole in Weber is denoted as phi, and Z is the total armature conductors. Assume that Z is known as total armature conductors and N is the speed of armature in 1 revolution per minute, RPM it is. A is the number of parallel paths in the armature winding. In 1 revolution of the armature, the flux cut by one conductor is. The flux cut by one conductor in 1 revolution is given by pi p. Suppose number of poles are there, in one conductor cut the flux by the number of poles into flux, that is Weber, make it as equation 1. Time taken to complete one revolution, another one, because the generated EMF depends on how many revolutions it made. The time taken to complete one revolution is given as 60 by N. If you assume N is the number of rotations, the time taken to complete one revolution is 60 by N. Therefore, the average induced EMF in one conductor will be E equal to P pi by T. Assume that it is make it as equation number 3. Putting the value of T from equation 2 in the equation 3, we will get E equal to P pi by 60 by N. That is P pi N by 60 volts EMF generated is, because E equal to N d phi by dt, that is Faraday's law. Based on that law, if you EMF generated is P pi by 60 by N, that is equal to P pi N by 60 volts. Make it as equation number 4. The number of conductors connected in series in each parallel path equal to Z by A. The number of armature conductors in each parallel path is given as total armature conductors divided by number of parallel paths. Therefore, the average induced EMF across each parallel path E equal to pi Pn by 60 Z by A, that is pi Zn P by 60 A volts, or E equal to pi Zn P by 60 A. Make it as equation 5, where N is the speed of the revolutions per second, RPS, and is given as N equal to N by 60. For a given machine, the number of poles and the number of conductors parallel path is Z by A or constant. Hence, the equation 5 can be written as E equal to K phi N, where K is known as constant, K equal to Pz by A. Therefore, the average induced EMF equation can also written as E is proportional to phi N. That means EMF generated in a generator or motor is proportional to flux and speed. That equal to E equal to K1 phi N, where K1 is another constant, and hence induced EMF equation can be written as E is proportional to phi N or E is proportional to pi omega, where omega is the angular velocity. Omega equal to 2 pi N by 60, it can be represented. Therefore, EMF generated in DC generator or back EMF equation of a motor is pi Zn P by 60A, where phi is known as flux per pole, P is known as number of poles, Z is total number of conductors, N is the speed, and A is the armature parallel paths, number of armature parallel paths. Simply we can replace EB equal to pi Zn 60A by 60A, that is back EMF equation of a DC motor.